Symmetry elements in crystals. Elements of symmetry and symmetry operation. A geometrical entity such as line or axis, a plane or a point with respect to which one or more symmetry operations may be carried out is called a symmetry element. Example: plane of symmetry, axis of symmetry, center of symmetry. The actions such as rotation, reflection, inversion, etc. are called symmetry operations. Axis of symmetry. Axis or line of symmetry is an imaginary line passing through the center of the crystal about which the crystal may be rotated so that the crystal presents the same appearance more than once in the complete revolution of 360 degrees. If similar view appears twice, an axis of twofold symmetry or dyad axis. If similar view appears thrice, an axis of threefold symmetry or triad axis. The symmetry element is axis and symmetry operation is rotation. These are examples of axis of symmetry. This is a fourfold axis of symmetry. The axis passing through the opposite face centers is a fourfold axis of symmetry. This means that a rotation of 360 degree same appearance appears in 4 times. This is a threefold axis of symmetry in which threefold axis passing through the diagonal corners of the cube is an example of threefold axis of symmetry, that is, after rotating 120 degree the same appearance appears, and full rotation of 360 degree 3 times the same appearance appears. The axis or line passing through the diagonally opposite edge centers is a twofold axis of symmetry for a cube. Then axis of 60-degree rotation. This is a hexagon, 60-degree rotation appears same structures, same appearance. Then 360 divided by 60, six-fold axis, complete revolution of 360 degree 6 times. Same appearance appears in 6 times. Then this is fourfold axis of symmetry, 360 divided by 90, fourfold axis. Then this is threefold axis, 120 degree rotation gives the same appearance. This is a twofold axis, 180 degree rotation gives the same appearance. Plane of symmetry. A plane of symmetry is an imaginary plane passing through the center of a crystal by which the crystal can be divided into two equal parts, each of which is exact mirror image of the other. Symmetry element is a plane. Symmetry operation is reflection. This is a plane of symmetry. A plane consisting of center of the crystal. This is another rectangular plane of symmetry. This is a diagonal plane of symmetry. Center of symmetry. A center of symmetry is a point at the center of the crystal so that any line drawn through it will intersect the surface of the crystal at equal distances on either side. This is the center of symmetry. Point at the center of the crystal so that any line passing through it will intersect the surface of the crystal at equal distances on either side at equivalent points. Okay, a crystal can have only one center of symmetry. Crystal can have only one center of symmetry to make have a number of plane of symmetry or axis of symmetry, but only one center of symmetry. And symmetry element is a point, and symmetry operation is inversion. The operation which we carried out to find whether the crystal have center of symmetry. A crystal has a center of symmetry is a operation inversion. That means any line drawn through the center of the crystal which intersect the surface of the crystal at equal points at equal distance on opposite sides or on either sides. Okay, this is the center of symmetry. A total number of planes, axes, and center of symmetries possessed by a crystal is called elements of symmetry of the crystal. A cubic crystal has 23 elements of symmetry.